webinar is about PhenoMobile, which is our ground-based high-throughput phenotyping product range at Hiphen. As you've seen in the previous webinar last year, we also have some product range regarding drone data processing, regarding phenostation, so regarding fixed high-throughput phenotyping at the same time for greenhouses and for also fruit phenotyping. Today in this webinar, there's myself, so Alexis. I'm the CEO and founder of Hiphen, and I have a PhD in high-throughput plant phenotyping, of course, and Nicolas. Hello, Nicolas.
Hello, Alexis. Hello, everybody, and thanks for joining us today. I'm Nicolas Chevier, Marketing Project Manager at Hiphen, and I'm really happy to be here today to introduce you our PhenoMobile product range. So without further ado, let's go straight into it. For those who don't know Hiphen yet, Hiphen is a company specialized in plant measurements with sensors. So we work with lots of devices and sensors today. And we basically combine deep agronomic knowledge with artificial intelligence to extract maximum value from crop images. Our team is composed of 20 plus agronomists and data scientists focused on delivering excellence. And I can mention the main interlocutors you may be in contact with. Of course, there's Alexis, but also Raphael, our COO, Joss, our CTO, Jeremy, the R&D project director, Alexandra, the R&D project manager that you may have seen in previous webinars, and then the business developers, which are Bruno and Lee. And today we're here to talk about PhenoMobile. So let's go straight with our systems portfolio. So PhenoMobile is about giving you access to ultra-precise plant measurements. So it's basically ground-based systems. And we have a portfolio of systems that comes from really high-end devices like PhenoMobile V2 and V1, which are fully autonomous robots, all the way to much more simple device, if I can say so, which are systems that can be embedded into tractors or machinery. And we have also gantry systems. Today, PhenoMobile has a lot of preferences yet. So it's mostly used by academics and research institutes. But we can also mention that industrials see potential in use of PhenoMobile to phenotype their field. So mostly seed breeding companies use this kind of device today. And I will let Alexis introduce you to each of the systems in detail.
So let's go straight into it. So there's different systems. So the first one is PhenoMobile V1. So PhenoMobile V1 is active at Arvalis, was acquired with Arvalis, was the first system delivered in 2015 from my memory. And it's a fully automated robot that enables you to phenotype low crops, so cereals and sugar beets. We worked a lot at Hiphen with this machine for sugar beet in order to detect diseases such as Cercospora, but Arvalis is using it routinely for the last 7 years now on wheat. And so there's a lot of phenotyping being done in the south of France with this machine. It's equipped with LiDARs, RGB cameras, a multispectral camera, and we will go deeper into it later in this webinar. This system is the system where we published the most out of it. So it's where really publications are really detailing the system. Two main publications, one that is comparing UAV data compared to UGV data regarding height. And one of the big findings in this paper, on top of the fact that it's a little bit more resolution, is a little bit higher with PhenoMobile, is that you can assess phenology and especially flowering by following height dynamics. So basically, when height is starting to stabilize, it's the flowering time. And this works really, really well. And it has been published in this paper that is in Frontiers in Plant Science. The other paper in Plant Phenomics is more detailing comparison between UAV and PhenoMobile in order to assess Cercospora, so disease on sugar beet that is really critical for many use, for many breeders to select on it. The question is a little bit different. Let's say that with PhenoMobile, we can have unprecedented resolution and metrics that allows us to be more precise than drones, way more precise than drone, and we debate our precision compared to visual scoring, so human being, and there are some points where we're slightly better, other points where it's quite equal, and I really invite you to read those two papers if you want to know more about PhenoMobile. Another system is a country system as well. It's owned as well by Arvalis. It's in Ouzouar-le-Marché, ou Vaison-la-Romaine now. They change names sometimes, the cities in France. There we're really in a logic of country to be able to assess way higher plants. So this type of country system allows you to measure wheat, but also corn and bigger things. What is really cool with the system compared to other systems we can see around the world is that it's really flexible in terms of being able to take different types of sensors. And so it's really flexible in the traits you want to assess. We'll discuss that later on. Another system, this time it's owned by INRAE. They have three of them, one in Toulouse, one in Montpellier, and one in Clermont-Ferrand, is what we call the PhenoMobile V2. So PhenoMobile V2 is a fully automated system where you have one person inside it, but just for legal issues. If we had no legal issues, we could remove this person from the PhenoMobile V2. It's amazing because it has an arm that can go up to 4 meter high and 11 meter further. So you really can phenotype any types of fields, any type of trails you have, and any types of crops. As well, huge versatility of types of sensor you can have. And I love this system, especially because we're working a lot with INRAE Toulouse on data processing. And Université Mohammed VI Polytechnique, based in Morocco, will have one delivered by June. So it's really something that is expanding in a system that is working really beautifully. Last system, but not least, we took the example of Icarda that acquired one, but there's many more at Arvalis or at some seed breeders. It's really about putting a measurement head on a tractor, on an existing device. Why? Because it's cheaper. So it's not fully automated. All the other sensors I presented to you are fully automated. There you need a driver, but the acquisition is automated. So when the measurement head goes on top of a microplot, it will start the measurements by itself, and it allows you to start with such system, with PhenoMobile systems, at way lower costs. So it's really something that I think is highly competitive, and we're really proud to process those data to work, especially with Icarda that we shown here. System we call the PhenoBuggy for its little name. So now that we showed you some of the systems that are around the world, so it's concrete stuff existing where data is being processed and used since 2015, even 2014, it was the first year that was a little bit tests. The big question, why should you use PhenoMobile when you have so many other devices to make high throughput phenotyping? Nicolas?
Thank you, Alexis. So indeed, that's a good question. Why choose PhenoMobile? Well, PhenoMobile is about giving you access to ultra-precise plant phenotyping measurements. But let's say PhenoMobile is the most expensive device that we can use for field phenotyping today. But meanwhile, it's also the most precise, accurate, and robust device we can use because being a ground-based system, the proximity with the canopy allows to capture really high-definition images. And these images, we can compute a lot of premium traits from these images. So that's really the power of PhenoMobile compared to drone, for instance. We can also mention that PhenoMobile systems are mostly flexible because, as Alexis said, going 4 meters high and 11 meters long allows to phenotype most crops. And that's really powerful, especially for research. And there's even more indicators that shows that PhenoMobile is the best package and the best solution to phenotype fields today. And talking about this solution, today PhenoMobile is relying on 4 main pillars, and they goes from highly customizable to highly standardized. And the first pillar is, of course, the mechanical structure. So this structure is, of course, all the systems that exist today. So that's the frame of the PhenoMobile. And As we say, it is highly customizable, since the fact that we can start with just a system embedded on a tractor you already have, or going to the high-end device with the fully autonomous robots. So this is really flexible. Then we get the measurement head with the sensors. So we can mention RGB plus flash, thermal cameras, and multispectral cameras. There's a lot of sensors that can be available, and we'll go into the details later on. But this is also highly customizable, since you can put a lot of sensors in a measurement head of a PhenoMobile. And since you can also upgrade sensors from one season to another, if you want to assess new traits, for example. Then we go to the mostly standardized pillars, which are acquisitions and processing. And so acquisition is made easy with PhenoMobile, especially with the fully autonomous robots, since they come as standard with an automated steering and acquisition software. So it gives you the ability to draw a map on the screen, and just the PhenoMobile will follow the map that you drawn, and the acquisition will be automated. So image triggering is automated. So it's really made easy. And then processing, well, processing is fully automated at Hiphen, with human in the loop for validation, of course. But processing happens in Cloverfield, which is our data platform, when you can access everything and browse your traits and access analytics. So we'll go into the details of that also later on, but this is highly standardized. Thank you, Alexis. And then, well, today, as you may have understood, there's lots of configuration that exist that are available to give really valuable data for you, from going to devices embedded into tractors to gantries and fully automated robots. There's for sure one to meet every types of crops needs and every types of research needs.
Thank you, Nicolas. Let's go into sensors now. And it's really something I would like to insist first, is that you're not truly interested, all the people that are attending this webinar, about which sensor you're putting in the system, but more about which traits you want to recover. And I think it's a big mistake that has been done often, not always, but often in phenotyping project those last 10 years, was to focus on the sensors and on the fancy sensors instead of focusing on which traits for which phenological or functioning of the plant you want to target. Often, and it's really surprising, and I know people, it hurts, but often RGB cameras can do a lot of work. Of course, RGB camera will not do everything, and lightning conditions are really critical. And that's one of the things that makes that RGB drones sometimes are not fully well working. Sometimes you need some diffuse light, sometimes you need some polarized light in order to remove specular effects. One of the most traits I wanted to talk to you about by showing RGB cameras is about width head counting. So width head counting, everyone speaks about it. Everyone says you can do it by drones. No one really routinely have it working by drones. So we're working hard with high-end drones to do it, and I think we'll succeed at one stage. Counting width head works for the last 3 years with PhenoMobile. So it's something that is already solved, working for breeders and for INRAE and Arvalis in a routinely way. We have demonstrated that counting with PhenoMobile is more accurate than counting with human beings. There's a publication made by Madek on this topic, and we highly help on the Global Width Head Detection Challenge, which enabled to have much more robust deep learning algorithm in order to count with heads. So RGB cameras allows you to do that. The next type of system you can embed is multispectral camera. And so what does multispectral camera give you? Well, it mainly gives you information about the biochemical content. So you have pigments. Those pigments are going to absorb some part of your radiometric spectrum and not others. And by looking at different wavelengths, which are not large wavelengths like with RGB, but narrow wavelengths, and also going into the near infrared or even a little bit further, allows you to have access to chlorophyll content, to nitrogen content, etc. It will also allow you to have a better precision in some diseases even though I believe that resolution is more important than spatial resolution is more important than spectral resolution. So sometimes RGB cameras can be enough for disease. At least that's really the way to go, I believe. Next, sensors that we embed a lot because it allows you to look at drought issues is thermal camera. So the first thing I want to say in the thermal camera is that it's really, really hard to calibrate. And the cool thing of having a thermal camera on a PhenoMobile and not on a drone is that you can have some black bodies to be able to calibrate your signal and thus to be able to say something of accurate regarding temperature, whatever is the change on your cameras calibration issue. Temperature gives you critical information about stomatal conductance, so basically about uh, if the plant is transpiring well or not, and combined with why not lysimeters, so that's what we're going to do in Morocco with University Mohammed VI Polytechnique. It can allow you to have unprecedented insights on how the plant is responding to water stress. I think after RGB camera, one of the most valuable system, and be careful, it's just LiDARs, not other RGB, not other 3D cameras that we'll discuss about. LiDAR are really amazing systems. It allows you to have height, it allows you to have volume, but it also is the most precise 3D system to be able to go within the canopy and to be having an idea of what is the density of matter within the canopy. So for that, there's a lot of work that has been done with terrestrial LiDAR. So LiDAR is more embedded on planes or so higher, working on voxels. And I believe that voxels is really a great way to go to retrieve a lot of traits about what is the quantity of materials you're having inside your canopy. We have some algorithm working routinely here, and we're really happy to speak further about that. How can you make a planetary index? How can you look at the structures of the leaf angles? How can you look at the ramifications, etc., using LiDARs? The other types of system that is used, so me, the use cases I've seen was mainly for comparison between satellites data and trail data. So when you have, a very small microplot that you cannot see with a satellite, even if some satellites now can have 3 meters or even 50 centimeters resolution. When you want to have a lot of modalities and to compare your signal with satellites signal, it can be cool to have hyperspectral information. So in this case, we show a spectrometer. It works quite well. It's also ways to have the same types of metrics you can have with RGB cameras or multispectral cameras, which is F cover, LAI, chlorophyll content, etc., but more in let's say, remote sensing type of algorithm. So I'm speaking about radiative transfer models. So really, you go into the radiative transfer models world with such type of system, and it's really cool to calibrate support management tools, for examples, for farmers. The last, and this is really what I want to insist, because there's a revolution in 3D sensors. So you're having now quite cheap or even very cheap 3D time of flight cameras, 3D line scanners, stereo vision cameras that can give you another insight of the 3D structure. So time of flight is a very flexible and today very cheap way of having some 3D point clouds, but has some drawbacks, which means it's used only in some specific conditions, which we use in vertical farming at Hiphen. 3D line scanners, so there's companies in the Phenotyping world that are using 3D line scanners exclusively. We believe it's great as long as you're having a small LAI, so not too much canopy, because there's more occlusion than with LiDARs. This being said, it gives you unprecedented quality of 3D point clouds, as long indeed as your LAI are small. And stereo visions can solve many things, especially being able to, when you have different heights, looking at the same footprints. So this is things we can do with lidars, of course, and combining RGB and lidars, etc. But there's some use cases and some traits that can be well accessed with stereo visions. And we're very happy in 1 hour we can make an audit of the traits you want and which are the best 3D systems you should have. And once again, we already have a lot of available algorithm to compute those traits. It's almost no more research anymore. The third pillar is about data acquisition. So there's two things to have about data acquisition. First way, if you have an automated system, well, the automated system needs to move automatically. And then it is about acquiring data, automated or not, within the microplot. So when you go and have your measurement head in the microplot, how do you trigger the different sensors one by one? For that, we have a software that allows you to do both in a very explicit way. And we're working very hard with all our customers and partners in order to make the calibration of the software. So to be able to integrate the microplot's boundaries, to be able to define scenarios, to define different scenarios depending the type of experiments you're making, etc., where you can trigger 4 images or 3 images, where you can start the LiDAR before the microplot boundaries or after, or where you want. I mean, you can want some different things. We already have some readily available scenarios, so it's very easy to get started with it, and it's also very flexible for you to do some specific types of acquisition if you have a specific experiment where you want to have some very subtle stuff. Also to mention, everything is saved into HDF5 formats. What does that mean? That means that it's really easy to access all the data and also all the metadata. So we have automated pipelines to process all those data and to get you traits, but the format is done in such a way that for you also, it will be very easy to be able to retrieve this data in an understandable way. Finally, Cloverfield, Nicolas?
Thank you, Alexis. So yeah, so we saw the three first pillars, so the systems, the sensors, and the acquisition. Now the processing. Well, processing, everything happens in Cloverfield basically. So Cloverfield is our online data platform built for scale that helps you to access all your traits, to inspect your microplots, to visualize trends and access some analytics, download your results also. So that's really one single platform that centralizes everything for you and your team. And we are trying to go, and we are actually going the step forward with Cloverfield, with monitoring performance dashboards, so interactive dashboards that we are currently building to help you browse your trait more intuitively, play with the data, understand everything about the data results that you get, and compare also to paleoclimatic conditions and much more features to access really quantifiable records and to understand what's about your data really. So today there's a lot of traits that are available for plant phenotyping with PhenoMobile. Most of them can be assessed routinely. We can mention, of course, disease quantification, but also with head counting, plant counting, and well, much more: plant stress, proxy of biomass, leaf area index. There's really a lot of traits, but not all traits can be assessed for all crops. So for that, we also have a process. Yeah, thank you, Alexis. We also have a process for that. It's basically a POC process with a feasibility study, the actual proof of concept, and the solution deployment if it's successful. So we work on that kind of topics with a lot of clients every year. So we help them develop new traits depending on their crops. So for example, if you are a fruit grower and you want to count organs for a specific crop, we can help you validate these new traits to be able to put it into production next campaigns. And this is really powerful to develop new things. And we are really looking forward to hear about your ambitions to develop new traits for your applications. And well, finally, last but not least, at Hiphen, our mission is to make image analytics more accessible to researchers and industrials globally. And we strongly believe that with PhenoMobile, we can help you really to save time and scale up, but also access outstanding measures and traits to understand new trials. All of that into a hassle-free acquisition experience with integrations and APIs and much more. So PhenoMobile is really a complete solution, ready to deliver value. And well, it's now time for some question, Alexis.
Yes. So we have up to now only one question. So please, if you want to ask more questions, don't hesitate. Nicolas Vierlet are asking us, what is the height of a buggy system? So the height of a buggy system depends on the buggy you're using. As we said, we're very flexible on that. The general height is 1.3 meters. So that's the classical one. But of course, if for some of your applications you need to go a little bit higher, we can help you find some other systems that can be higher. Do you have other questions? We still have 4 minutes before making half an hour, so we were really happy to do a few little bit longer.
Yeah, someone is typing.
Yeah, so if you have any thoughts of any needs, any ideas you would like to want, or having some ideas also on the price, because it's really hard to give you some prices like that without knowing your project, etc. Please don't hesitate to write to us. We're always happy to answer to your questions, and we're always happy to give you some price ranges depending on yeah, what you phenotype. I mean,
yeah, you can send us a message quite easily on our website, www.hiphen-plan.com, and you can contact us to ask us anything. Yeah.